Okay, and I'm back, and we're continuing with Sudokuvania, Digits of Despair. I cleared out my cache accidentally, but I had an error anyways in them, so... Oh, shoot. I don't even remember which one. Shoot. I thought I cleared the cache for 7 days. I was having some issues. Um, when I got back from my vacation. Well, let's start over from the beginning. We had to start over anyways because there was some bug, or not bug, but we were having some issues with the setup. Anyways, okay. Where is 6? 6 cannot be here or here in this 2x3 box. Therefore, this must be a 6 here. 4 cannot be here or here in this 2x3 box, so it must be here. 5. Where's 3? 3 cannot be here. Where's 3 in this 2x2? It has to be here. This is 1 and 2. We have... Where's 6 here? 6 cannot be here or here. 6 has to be here. So this is a 6. Unlike unlocked guide at Thermo. Okay, what are the thermos? Digits along a bronze go to thermo, strictly increase. Okay, so that's, yeah, that. Again, we needed to... Okay, so this can't be 4. Where is the 4 here? This has to be a 4, which makes this a 1-5 pair. This is a 2-3 pair. We have missing now... This is 1, and we're missing a 5. We have a 4 here. This has to be greater than 6. 5 can't be here. This is 1, 2, and 5 here. This has to be 3, 4, 1, 2. This can't be 4. 6 is one of these, but we're not sure which. 1 is one of these 3. 5 is one of those 3. We have 2 and 3 here. Okay. This has to be at least 7, 8, and we know it goes to here, so this is 9. So it constantly increases, so this is 7, 8, and 9. Maybe? I think I had this wrong. Did I? I don't know. It's been so long since I've... and I guess I reset. Well, anyways. Right. 7, 8, and 9. So 9 cannot be here. 9 has to be one of these two. No 4. This can't be 9, 8, or 7, so this is at most 6, at most 6, at most... Okay, this has to be an 8, 9 pair here, then. So this is an 8, 9 pair. This is 5 at most. This is 6, 5, 4 at most. 5, 4, 3. So this could be 1, 2, 3, 2, 3, 4, 3, 4, 5, or 4, 5, 6. This is at least 1 through 4, 2 through 5, but no 4. Oops, we have a setting problem here. No conflict checker. Wow, this reset all my settings. I don't know how it did that. Check pencil mark off. I don't know why it saves certain ones and okay, well we want to enable letter tool. I like that, and I like pen tool actually. Anyways, I'm not sure why that happened. This is at least 3. So we have 6 has to be one of these two. We have the 8, 9 pair here. 4 cannot be here. That means 1 has to be one of these two. Since 1 is one of these, this cannot be 1. This has to be 5, which makes that a 1. Because 1 cannot be any of these. This can't be 5 either. This can't be 1. This cannot be 1 because of the 1 above it. So this is this is 3, 4, 5, and 6 here, which forces this to be a 1, 2 pair, which forces this to be 3. So this is 3, this has to be 4, this is 5, this is 6, which makes this a 3, this is 2, and this is 1. And we see the boss. This is very different. Did I mess this up really badly? What's going on here? That's weird. This becomes 1, 3, and 7. Because this is quite different from what I had previously. This can't be 1 because of this 1. It's very strange. I swore I didn't... This didn't look like this. I know I didn't look like this. I don't know. Anyways, these two are 8 and 9 left. Maybe I messed up at the very beginning. I don't know. Let's go to the boss. Blah, 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 blah. Increase, blah, blah, blah. Increase from the bulb to the tip. So 1, 2, 3, 4, 5. 5 through 9. Okay, so we have a lot of those. So that's 1 through 5. These are 2 through 6. These are 3 through 7. These are 4 through 8. These are 5 through 9. Okay, so again, we can't have 8 and 9 here, because then that would be leave at 8 and 9 here. This can't be 7 with 8 or 9, because again, that would leave both of them here. This can't be 6 either, because this is always going to be greater than this. So these two digits would then have to be here. So this can't be 6, 7, or 8, which means this can't be 5, 6, or 7. Can't be 4, 5, 6, and no 3, 4, 5. I think this is similar, but the other way, right? Right. Can't be here. We have a 1, 2, 3, 4, 5 quintuplet now in box 4, which leaves these as 6, 7, 8, 9. Similarly here, these two digits must be less than all 3 of these digits, so cannot be the same. So both of these digits cannot be the same as this. Therefore, both of them, one of them has to be one of these two here. So this is at least 5 or 6, which means no 3, 4, 5, no 4, 5, 6, no 5, 6, 7. Therefore, one of these is 5. One of these is 5. Since one of these is 5, that means it must be 5, 6, 7, 8, and 9. If one of these is not 5, this is 1 through this. One of these has to be 5, which makes it 5, 4, 3, 2, 1. So this cannot be 9, because it has to be 5, 6, 7, 8, and 9, and then 5, 4, 3, 2, 1. So this becomes a 5, 9 pair, and this becomes a 1, 5 pair. That means this can't be 1, this is 2, this is 3, this is 4, which makes that not 4, this is 5, which means this can't be 5. So it's 6, 7, 8, or 9. 5 cannot be any of those. This similar can't be 9 because of the 5, 9 pair in the box. Therefore, this is 8, this is 7, this is 6, this is 5 because it has to be less than that. And this is 1 through 4. So these digits are 1 through 4. This cannot be 3 here. One of these two is a 3, so this can't be 3 there. These can't be 7. This can't be 6. So this is either 1, 2, 3, 4, 5, or 5, 6, 7, 8, 9. So this is a 2, 6 pair. This is 2 or 6, 3 or 7, 3 or 7, 4 or 8, and 4 or 8 here. The rest of these digits are 1 through 4. This cannot be 1 or 5. The rest of these digits are 6 through 9. But 9 cannot be any of these, right? This is 1 through 6, 2 through 7, 3 through 8, or 4 through 9. So 9 has to be one of these 3 digits, which means this cannot be 9. This cannot be 9. One of these 3 is a 9 here, but this can't obviously not be a 9. This has to be greater than that digit, so this can't be 6. This is a 3-7 pair, so this can't be 3 or 7. This can't be 2-6 pair, so this can't be 2 or 6. This can't be 1 or 5. No 4 or 8 here. So this is 9. This cannot be 3, 2, 1 because that would eliminate 3 possibilities for these 2 cells, and therefore these 2 cells would have to be the same digit, which is 4. It can't be 4, 2, 1, or 4. Yeah, it would have to be 4, 2, 1 if this is 4, because of the same problem here. So this is 5, 7, or 8, which makes this 6, 7, or 8. This is 6, 7, or 8, so this can't be 8. This becomes 5 or 7. One of these is a 5. So one of these 2 digits is a 5. This is 5 here. So one of these 2 digits is a 5. And the remaining digits are... Okay, 9 cannot be here again because of this 9. So 9 has to be one of these 2 cells in column 8. 9 has to be one of these 2 cells. So 9 has to be one of these 2 cells here. This becomes 1... This is 1 through 4 here. 1 through 4 and 9 here. This is just 1 through 4, and these could be 5. Okay. This is 1, 6, 7, 8, 9. There is no equivalent 1 here, though. I don't remember exactly how I solved this, but I have a vague remembrance. This can't be 6, this can't be 8. This is 1, 2, 3 at most, or at least. Up to 9, there's no 6. One of these is a 5, so this can't be 5. Oh, 5 cannot be here or here, so 5 is one of these 3 cells. 7 cannot be there, obviously. This could be 2, no 3, 4, 4, 5, 6, no 7. It could technically be 8. This is 1 through 7 without 4, without 5. So 1 through 7, okay. This digit cannot be any of these digits. Okay, that's how I solved it. So this digit must not be one of those digits because this has to be specifically less than that digit. So the digit has to be here, which means it must be 6, 7, or 8 here. So this has to then be 6, 7, and 8, which makes that a 9. That's a 5. This is a 1. This is a 5. This can no longer be 1. This can't be 1. So this can't be 2 here, which means this can't be 3 or 4. This is 7, 8, or 9. Can't be 9 here. This is a 7, 8 pair. This can't be 2, which leaves this as a 1, 3, 4 triplet here. But this can't be 3. One of these is a 3. We're not sure which. This 7 means this can't be 7. This is 3. This is 2. This is 4, which means this can't be 2, 3, or 4. This is a 1, which means this can't be 1. This can't be 1. This is 6, 7, 8, 9. 6, 7, 8, 9. 6, 7, 8, 9, but technically you can't have a 9, and this has to be less than this, so this is 6 or 7, this is 7 or 8, this is 8 or 9. We have a 6, 7, 8, 9 quadruplet in box 3, so this leaves this as 2, 3, and 4 because the 5 can't be there because of that 5. We have a 1, 6, 7, 8, 9 quintuplet, in box 1, which eliminates 1, 6, 7, 8, 9. So this is 2, 3, 4. This is 2, 3, or 4. We have a 2, 3, 4 triplet in row 1, which eliminates 2, 3, and 4 in the rest of the row. So this is 5, which means this can't be 5. 5 has to be one of these 3. And there's no 2, 3, or 4 involved. Okay, that's interesting. So because of the 2, 3, 4 triplet in the row. So this has to be 1, 6, 1, 5, 6, 7, 8, 9. Well, this has to be less than this, so this has to be 5, 6, 7, 8, 9, or 1. This can't be 8. This can't be 7. This can't be 6. That doesn't help very much. This is 7 or 8, so this can never be 8. It's 4, 5, or 6, which makes this less than that. It's 2 or 3 here. This can't be 4. It's 1 or 3 here. This can't be 7 anymore, so this becomes 5, which makes this 2 or 4 at most, which makes this 1, 2, or 3 at most. We have a 1, 2, 3 triplet here in column 6, which eliminates 1, 2, and 3 in the rest of the column. So that leaves 5, 6, 7, 9. This can't be 7 because of that. 7, 5, 6, 7, 9. 5, 6, 7, 9. But this can't be 5, 6, or 7. So this must be a 9. This 9 means this can't be 9. This is 5 or 6. This can't be 9, and that can't be 9. Therefore, this can't be 8 because this must be smaller than that. This 9 cannot be here. This is 1, 2, 3, 4, but we're not sure which one it is. This is not 3 here, though. This is not 2. We have a 1, 2, 3, 4 quadruplet in column row 9, which eliminates 1, 2, 3, and 4 in the rest of the row. This can't be 5 either, so it must be 6, 7, or 8, which leaves the 5 being here. So this can't be 5. This cannot be 6, 7, or 8. Cannot be 1 because one of these two has to be 1. Therefore, that leaves this as a 9, which means this cannot be 9. Whereas the 9 in box 9, it must be here. So this is a 9. We have 1, 2, 3, 4 remaining here. 1, 2, 3, 4. But this can't be 1 because it must be greater than that. Therefore, this can't be 4. We know the one already was here. This is a 1, 2, 3, 4 quadruplet in box 7, which eliminates 1, 2, 3, and 4 in the rest of the box. Therefore, it's 6, 7, 8. This is 6, 7, 8, and this is not this. This is 6, 7, or 8 here. We know the 8 must be one of those two cells, so this can't be 8 because of this 6, 7, 8 triplet. None of these can be 9. So 9's one of these two. This can't be 4. We now have a 2, 3, 2, 3 pair in the rest of row 4, which eliminates 2 and 3 in the rest of the row. So this is 6, 7, or 9. But this can't be 6. This can't be 7. The 7 cannot be here, the 7 cannot be here, and the 7 cannot be here. One of these two must be a 7, which means this can't be 7. One of these two must be a 7, so this can't be 7. What else do we have? So 8's here also, but that doesn't help us much. If this is 4, this would have to be 3. No, that's not true. If this is 3, this would have to be... No, it doesn't have to be. This would be 1, 4. This would be 5 or 6, but that doesn't tell us anything. Okay, where's 2? 2 can't be here. 2 can't be here. 2 can't be either of these because of the 1, 2, 3 triplet here. This can't be 2 because of the 2, 3 pair here, and this can't be 2 because of the 2 here. So 2 is eliminated from there, 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 and there. Therefore, where's the 2 in box 5? It must be here, which makes this a 3. This cannot be 3. This is 2, which means this can't be 2. We have a 1, 3 pair here. One of these is 7. 3 is here. 3 cannot be here. Where is the 3 in box 5? Can't be here, can't be here, can't be here, can't be here. It must be here. So this is 3, which makes this a 1. This can no longer be 1. This can't be 1, so therefore this can't be 2 here. We have a 2, 4 pair in row 8, which eliminates 2 and 4 in the rest of the row. Therefore, this is 3, which makes it out of 4. So this can't be 4. This can't be 4. None of these are 4, and these can't be 3. This can't be 2 or 3, therefore this is 4, which makes this not 4. This can't be 4 either. One of these 2 was a 4. 5 cannot be here. We already knew that though. This is 1, 6, 7, 8, 9. 6 cannot be here. 7 cannot be here. This can't be 5. Where is the 3 now remaining in column 4? Can't be here because of the 3 in the box. Can't be here because of the 3 in the box, and these are filled. So this must be a 3, which means this cannot be 3. This can't be 1 because of that 1. We have a 2, 4, 2, 4 pair in column 5, which eliminates 2 and 4 and the rest of the column. So this is 1, this is 4. None of these could be 4. So 1 is here. This is what? Cannot be 5. We have a 2, 4, 2, 4 pair here, which eliminates 4 here. That makes a 5, 6, 5, 6 pair in box 5, which eliminates 5 and 6 in the rest of the box. Therefore, this is 9, this is 7, this is 8, and this must be 4. This 5, 6 pair eliminates 5 and 6 in the rest of the row. So this is an 8 and 9 pair, which eliminates 8 and 9 from the rest of the box. Therefore, this can't be 8 or 9. This is 7. This can't be 7 or 9. It's 6, which leaves this as 8 or 9. This is 5 or 6. This is 5 or 6. This cannot be 1, which means this can't be 5. We have a 6, 7, 6, 7 pair in column 6, which eliminates 6 and 7 from the rest of the column. Therefore, this is 5. That makes this 6, which makes that a 5. This can't be 1, 6, or 9, so this is 8. None of these are 8, and it can't be 7 either because of the 6, 7 pair in the box. This 8 means this can't be 8, so this is 9, which means this can't be the 9 here. This 9 means this can't be 9, so it's 1. This is 9. This can't be 1 or 8. That's a 6, 7. Where's the 1 in column 1? It has to be here. So this is 1. This can't be 9 because of that 9, so this is 8. Where's the 9 in the rest of the box 1? It must be here, which makes this 8, which makes that 9. These can't be 8. This 6, 7 pair means this is not a 6 or 7 in the same box, so this is an 8 here. This can't be 8. Where is the 8 in box 8? 9. It has to be here. Okay, so this is 8. We have a 6, 7 pair in row 3, which eliminates 6 and 7 in the rest of the row. So this is 8, which makes that a 7, which makes that a 6, which makes that a 7, which makes that a 6, which makes that a 7, which makes that a 6. 1, 2, 1, 2. Where's the 4 in column 7? Actually, this can't be 6 anyway, so this is 7, which makes that 6. This 7 makes that a 6, which makes that a 7. We need a 4 in column 7, so that has to be here. This can't be 4. This can't be 1. Well, where's the 4 in column 9? It has to be here. So this is 4, which makes that 2, which makes that 4, which makes that 2, which makes that 1. Therefore, it's a 2, which makes that a 3, 1, 2, 1. This 2 means that's a 3, 2, 3, and a 2 there. Yeah, that was much faster, but I already knew a lot of this details here. What's the solution again? What do I need to put again? Enter 3 in this puzzle box's cells of Sudokuvania. Okay, so we're going back to here. Resume. Oops, we zoomed in the wrong place. Let's zoom here. This we know is a 3, which means this can't be 3. This is 7. None of these can be 7. We unlocked some whip, which is the arrows, I believe. I feel like this is different. I don't remember this 4 being here. Maybe it was, but we need a reset because I can't see the rules. Let's continue. We can't see any of that. And it's zooming out weirdly again. This is one problem with this, is that it's really hard to navigate this. Why is Fen popping up? I thought I removed that. Oh, it's off. Okay. Okay, cells on a whip sum to the digit, so that's typical arrow Sudoku. Okay, that's fine. So this is a thermo, so one cannot be here, one cannot be here. Okay, so what were the choices here? The remaining digits here are 4, 5, 8, and 9. That didn't change much. The rest of this column is 2, 5, and 6. The rest of this column is 1, 4, and 7. I don't remember this being that easy. Anyways, let's continue. 1 cannot be either of these, so 1's either here or here, because it can't be here. This cannot be 1 and 2 adding up to 3. Cannot be 1, 3. Could be 1, 4 adding up to 5. That's possible. It could be 2, 4 adding up to 6. That's also possible. This is at least 2, which makes that at least 3, but it can't be 3. This is at least 4. So this is 4, 5, 6, 7, 8. But this can't be 8 because this can't be 1, because this is at least a 2. 2, 3, no 4, 5. It could be 6, 7, 8 here. It can't be 6, 7. It has to be less than 4, 5, 6, or 7. So 1, 4 adds up to 5. 2, 4 adds up to 6. 1, 5 adds up to 6. 1, 6 doesn't work, though. We have to add up to 5, 6, or 9 here. And it would have to be 4, 5 if that's 9. This is at least 6 because it's 2 and 4 at minimum. Which could be 3. It cannot be 4. Okay, this can't be 6. So it could be 7 or 8 specifically. So this can't be 7 because that would require 1 and 7 to add up to 8. This is 2 or 3, which is with 4, 5, or 6 here. So this can never be 6. We have a 2, 3, 2, 3 pair in box 5 of this grid. So this can't be 2 or 3. This must be either 1, 4 adding up to 5, 1, 5 adding up to 6, or 1, 4, 5 adding up to 9. We're not sure which. Okay. What else do we have here? The rest of this box. Rest of row 4 has to be 1, 2, 4, 5, 6, and 9. But this can't be 1. It can't be 2. It could be 4, 5, 6, or 9 here. So we know the 2 has to be one of these two. This is 1 or 2 here, which means this is 2, so this cannot be 2. This has to be 1, which means this can't be 1. This is 1 with 4 or 5 here, so this is 5 or 6. Right? Because we know 2 had to be here. 2 cannot be here. This is, as this is less than this, it has to be 1 or 2 with the 2 or 3. This can't be 6. So if this is 7, this is 2, 5, or 3, 4. If this is 8, oh, this is a 4, 5 pair here. So this is 1 with 4 or 5 to add up to 5 or 6. This is 4 or 5 because it can't be 6 or above to add up to this cell. And it has to be greater than that. And it can't be a 3. So there's no 4 or 5 in the rest of this box. This is a 1, 2, 3, 4, 5 triplet. So this is 7 and 8. This is 6, 7, 8, and 9. This 1 means this can't be 1. So this is 2, which makes this a 1, which makes that a 3. This then must be a 2. So it must be 2 and 5 adding up to 7, which makes that an 8. This can't be 5, so this must be 1 and 4 adding up to 5. This is a 2, 6, 9 possibility. These are 3 and 4. This is very different, I feel. Anyways. 7's one of these. 8 cannot be here. So 8's one of these with 6 or 9. This can't be 5. Anyways, 3 cannot be here or here. So 3's one of these two. This is a 1, 4 pair. These, What does this mean? I can't tell where. Does it go down? I think it goes down. So either it's 1, 2, 3 here or 1, 2, 3 here. 3 is here. 1 cannot be here. So 1 has to be one of these 4. 8 could technically be here, but we don't know. This is not the circle part of the whip, sum whip. And 1 cannot, 1 could technically be here. I think this has to be 2 and 4, right? 1 and 3 can't be here. I guess it could be 2, 5. We need a 2 here, basically, is the point, right? Because there's no, that we know 3 of the digits add up to at least another digit. So one of these is the circle. We're not sure which, but none of these can be 1 and none of these can be 3. So it's 2 with 4, 5, or 6. So we know 2 is here, and then 4, 5, or 6 are here. Can't be 5, though. So this can't be 2. Hmm. Remaining digits in column 7 are 2, 3, 4, 6, 8, and 9. That doesn't tell us very much. This can't be 2 or 3, though. We don't know which way this thermo goes. I think we need a 1. Yeah. If it goes this way, and this is 2, 4, we need, yeah. In anytime you have 3 unique digits adding up to another digit, which this has to be, you have to have a 1, 2 out of 1, 2, and 3 there, at least. Right? Because the minimum obviously is 1, 2, and 3, but if you try to have the maximum, which adds up to 9, you have to have either 2, 3, 4, 1, 2, 6, or 1, 2, 1, 3, 5. And we have a 2 here, we need a 1. So this must be a 1, which means this cannot be 3. So this can't be 1 or 3 here. So we can remove that. This must be then a 3. Because that's no other place for it. This is 2. It has to have, it's either 4, 5, or 6. Cannot be 5 anymore. Because if it's 2, 1, 2, 5, that adds up to 8, and that can't be 8. So this is 7 or 9 here. This is 2, 4, 6 here. This is greater than that. Cannot be 3. Cannot be, could be 4. That could be 5. So this is 9 at most. This is 8 at most. If this were 6 and 2. If this was 6, this would have to be 2, and this would therefore be 9, but that's not possible. So this cannot be 6. What do we have left? We have no 2. Could be 4, 5, 6, 7, 8, and 9. 8 can't be here. 5 can't be here. This can't be 3. So 3 is one of these 3 digits. What else do we have? Okay, this, well, it could be 4. Okay, we know 9 has to be one of these 3 digits because none of these can be 9. So this can't be 9 here. This can't be 1 because of this 1. I don't remember this. I do remember I did get kind of stuck here, but I went this way, I think, but Okay. If it's 5, this is 4, 2, 6, and 9, and therefore this would be 7 and 8. That seems possible. Hmm. Mm. Hmm. Hmm. Man, this feels like it's solving it's solving this all over again. Hmm. Uh, let's fill this out more. Okay, so this is 2, 3, 6. We have 1, 5 with 2 or 3. This is 1, 2, 3 here. And this is 4, 5, 6 here. Hmm. Let me reset. Okay, I don't remember how we solved this part. I do remember vaguely some logic here, but I don't remember any specifics. I do remember this sort of 6-9 thing, which eliminated 6 there. I don't know if I remember anything else, though. Hmm. Okay, this can't be 4, because if this is 4, this becomes 2, which would force that not to have a digit. So this is not 4. This can't be 5, then. Hmm. The remaining digits in column 6 would be a lot. 1, 3, 4, 5, 6, 7, 8, 9, but no 1. Oh. Where is the 1? There we go. Okay. Well, that's one thing. So this 1 means this can't be 1. So this is 4, which makes this a 1. This 4 means this can't be 4. So this is 2 or 6. This can never be 7? Because if this is 7, this becomes 9 with... Oh, I guess it could still be 7 here. Hmm. We have 3, 4, 5 here. The remaining digits here are 4, 5, 6, 7, 8, and 9. But this can't be 4, and this can't be 5. This can't be 4 because of this 4. None of these could be 4. Where is the 4 then? 4 has to be in column 6, has to be one of those two. 4 we know is one of those two then. Ugh. The remaining digits in column 5 are 2, 6, 7, 8, and 9. But that's not helpful. Uh, Many digits here can be 1, 4, 5, 6, 7, 8, 9. And it still could be any of those. Ugh. 2, 4, 6. If this is 6, this becomes 2. This is 9. This has to be 7, 8. Ah. So that can't be 6. I think that's where I found it. So if this was 6, this would have to be 2. This would be 9. But this 6 would have to be followed by 7 and 8 because the 9 is already there. But then this would have an 8-9 pair here, which eliminates 8 and 9 from that cell, which eliminates all the possibilities. So this cannot be 6, therefore this is 2, this is 4. This can't be 4, this has to be a 7. Which means none of these are 4. This can't be 7, this can't be 7, this can't be 4 or 7. Oops. This can't be 7 here. Remaining digits are 2, 5, 6, and 9 in column 4. This can't be 2. Right, these arrows add up to this. These two arrows add up to this. 9 can never be on an arrow in the arrow part, so this can't be 9. Which means where's the 9 in row 7? It must be here, which means none of these are 9. One. Okay, so this cannot be 1 here. This can't be 8. This is at least 2 because it can't be 1. This is at least 3. So 3 through 8 is possible here. This has to be 2 through 4 because this one has to add up to at most 9. It can't actually add up to 9, so this can't be 4. This is 2 or 3. This then can't be 8, which means this can't be 7. This still could add up to 9, so that's fine. This is at least 7 or 8. So this can't be 7 here. This is 5 or 6. We have a 5, 6, 5, 6 pair in row 7, which eliminates 5 and 6 from the rest of the row. So this is 1. That makes this a 7. This has to be 8, which makes this a 9. This 8 and 9 eliminates this 8 and 9, so this is a 6, which makes that a 5. This can't be 6 anymore. This can't be 9. No 8 or 9 here. No 6 here. No 5 here. No 6 here. Okay, where's a 9 here? It has to be one of those two. This has to add up to 6, 8, or 9. Therefore, it cannot be 3. It must be either 5, 7, or 8. It can't be 7, therefore this can't be 8. Whereas the 8 in row 6, it must be here. This is a 6 or 9 with 5 or 8 adding up. This can't be 8 anymore, so this must be 5, which makes that a 6. That makes this a 6, which forces this to be 2. Therefore, this is an 8. None of these can be 8. This has to be a 3 because that's the only digit remaining. Then we have a 2, 4, 2, 4 pair here. This can't be 8. This can't be 6 here. This can't be 6, so this is 7, which makes that a 9, which makes that a 6. We have a 2, 9 pair here. 2, 4, 2, 4. This is 8. No 3 here. This can't be 5 or 8. Right, and I do remember this being not filled out. So that was actually, I think I'm mixing up these two. I think I did have something like this. Anyways, What did we unlock another rule set? I don't know if we remember doing that. We did not. Okay, so let's continue with this. Remember, this 1 cannot be in the same box here, therefore this is a 2, 3, 4 triplet. This cannot be 2, 3, or 4, so this is at least 1. This cannot be 2, 3, or 4, so this is at least 5, which makes this at least 7. So this is 7, 8, 9, 5, 6, 7, 8, and this is 1, 5, 6, or 7 here. This must be a 9 here. So this is a 9, which means this can't be 9, this can't be 8, this can't be 7. This can't be 1 anymore because it must be greater than that cell. So this can't be 5. This can't be 6. This must be 7, which makes that an 8. This is a 5-9 pair here. This is 5 or 6. This is 4 or 5. That's interesting. This is 3 or 4. Or it could be 1. If it's 4, this is 1, 3. If it's 5, it could be 1, 4, or 2, 3. Can't be 1. So it has to be 2, 3, which forces this to be 5, which makes that a 6. This can't be 1, 2, or 3. So this has to be 4. Which makes that less than that. This is 3, this is 2, and that's 1. That leaves these digits. This can't be a 1 because of that 1. So where's the 1? In box 2, it has to be here. This is a 4. The remaining digits here are 7 and 8. The remaining digits here are 5 and 9, but this has to be greater than these, so this must be 9, which makes this a 5. We've unlocked Whisper Dash. I don't remember what Whisper Dash was. Okay. Whisper line, German whisper line, right? Okay, so the remaining, okay, so this must be at least 6. So we have 1, at least 2, 3, 4, 5, 6, which is fine. 7, so this is at most 8. 7, 8, 6, 7, 5, 6, 4, 4, 5, 3, 4, or 2, 3. Okay, so we have German whisper line. These digits add up to that, but that's not helpful right now. This is 6, 7, or 8, which forces this to be a German whisper line, and this is a German whisper line, so this is 2 or 3 here, but it can't be 2. Therefore, this must be a 3, which forces this to be 8. None of these can be 8. This cannot be 2 anymore, so it must be 1 here. One of these is low, so one of these must be a 4 because we have 1, 3, and 2 already, so this can't be 4 here because that would force us to be 9, and we can't have 9 here. So this is 4 and this is 9. Okay, this I do remember. We have 7, 8, 7, 8, 6, 7, 8 here. We have 5, 6, 7, 8 remaining in row 4. This can't be 8. 5, 6, 7, 8. No 5 here because of that 5, 5, 6, 7, 8. Okay, that's fine. One of these, okay, so if this is 6, one of these is a 1. And it could be 7 or 8. It cannot be, it could be 1 or 3 here. But 8 cannot be here. So if this is 1 or 7, if this is 1, this is obviously 6. If this is 7, this actually has to have a 6, which means one of these is a 1. So we know for certain one of these is 1. Therefore, because one of these is a 6. One of these has to be high, cannot be 7, 8, or 9, because they see all of those digits. So one of these is 1. If this is 7, it has to be 1 here, so this cannot be 3 here. but this could be 8 if this were 3. That's also possible. This can no longer be 6 because one of these two must be a 6. Let's see. Do we have anything else? There must be a high here because it must be paired with a low. Does that tell us anything? Not particularly. Remaining digits in row 1 are what? 3, 4, 5, 7, 9. But this can't be 9. Been a while. I don't remember this part. One has to be one of these two. We do know one has to be one of these 4. That doesn't help us much. It's been a while, so I don't remember which one was which. 8 is... Okay, this can't be 9. Therefore, this is 5, which makes that a 9. Okay. This has to be all low then, because it cannot have a... No, actually, it has to have an 8. Cannot be 6, 7, or 9, or 5. So this is 1, 2, 3, 4, and 8, but we're not sure where the 8 is. One of these is 7 or 8. We know the 1 is here. So this cannot be 1 here. We have 2, 3, no 4, 5, 7, or 8. This is 9, because it was only 5 or 9 as the choices. What else do we have? 6 or 7 can... Both of them can be next to 1. This is at least... Oh, where is this digit? It cannot be 2 and 3. So it's 2 and 4, at least. Can it be 2 and 5? Can it be 3? I guess it could be. Okay, so this could be 2, 4, adding up to 6, 7, or 8. This could be 3. 6, 5, 6, right? So we know 8 has to be one of these two digits because this can never be 8. This can never be 8. So this can't be 8 anymore. Therefore, this is 6 or 7 here. This can no longer add up to 6. So it's either 2, 4 adding up to 6, 2, 5 adding up to 7, or 3, 4 adding up to 6. So this is... One of these is 2 or 3, which means that one of these is 2 or 3. Which means 2 and 3 cannot be in the rest of the box. Therefore, this is 4 through 8. And we're not sure which. Okay, remaining in grid 2, the remaining digits in column 9 are 2, 5, 6, 7, and 9. That still could fit any of them. The remaining digits in column 7 are 2, 4, 6, 7, 8, 9. We know this is 1, this is 3, this is 8. Do we have anything else right now? It sucks to have lost all the progress we made. Even if we were gonna reset, it would have been nice to have all the information that we're not having to resolve. 1, 3. Can this be 8 and 3? Yes, maybe. Which would force this to be 8. Remaining digits here. No 6, no 2, no 8, no 9, 3, 4, 5, 7 with 1. Huh. What are we looking at now? 5 cannot be here, cannot be here. Okay, so 5 is one of these 3. We know 8's one of these 3. 5 has to be one of these 3. 3 is one of those 3. None of this is very helpful. Anyways, this can't be 8 here. Yeah, I think I've messed up here previously. So, but this still doesn't resolve right now. We do know 4 has to be one of these 3. I guess that's kind of helpful. 5 does not have to be, though. Whisper. This still could be 8 here. That's a little problematic. Ooh. I remember I did get kind of stuck this way, too. I don't remember how I solved my way out of this, though. Six has to be one of these 2 digits here. 6 is also one of these 2 digits. That's not that helpful. Oh, none of these can be 7. This becomes a 4, 5, 6 triplet, which eliminates 4, 5, and... Okay, this can't be 6. This can't be 9. Does that help any? I don't know if it does. This can't be 4 because of this 4. Remaining... this 2 means this can't be 2. Therefore, this is 9. This is 2. This can no longer be 9, so we have a 4, 5, 4, 5 pair in row 3, which eliminates 4 and 5 from the rest of the row. This can't be 4, so this is 9. This can't be 4, so this is 8, which means this can't be 8. This 2 means this can't be 2, so this is 4, this is 2. This 4 means this can't be 4, so this is 3, this is 4, which means none of these could be 4. This can't be 4 anymore, so this is 5, this is 4, which makes that 6, which makes that 5. This can't be 6 anymore, hence this is 6. This can't be 2 or 6, so this is 4. We have what? 1 and 7 remaining here. And this is 2 and 3. This 7 means this can't be 7, so this is 4, this is 1. I'm not sure what this is, but anyways. This can't be 6 because of this 6, so this is a 5. This can't be 2 or 5, so this is 6, which makes that a 2. This 8 means this can't be 8, so this is 9, this is 8. Why isn't this cleared out? Anyways, that's kind of annoying. These are still the same. 6 and 2 add up to 8. 5 and 1 add up to 6. Okay. Doesn't mean this has to be a 9. And we don't know. Huh. Unless I get more information here, I'm not sure how to solve this part. I don't think I've unlocked another rule set, right? I remember what this rule set was here, but I don't remember how I unlocked it is essentially the problem, right? I remember I cleared out some of this stuff, but I don't remember how I cleared that out. That was really the issue, right? Oh boy. We know 5 is one of those. Because 5 cannot be on a German whisper line, which is what these are. Oh, this can't be 4 anymore. This cannot be 4. Which means none of these could be 4. Which means 4 has to be one of these two. Which means 4 has to be one of these 3 then. Because 4 could only be next to 9 on a German whisper line. I guess this teaches people a lesson. Don't clear out your caches if you're still doing some Sudokus. I get. Yeah, I don't know. We still haven't found the boss here. But the thing is, I remember unlocking this one first. I don't remember. Did we mess up? I don't think we did. Hmm. Okay, so 4 has to be one of these 3 cells here. Hmm. Oh, I see a problem here. No, I see multiple problems here. Okay. Hold up. Okay. How did I do this? Okay, this is all weird here. Yeah, I don't know how. No. This can't be 2 because of this 2. So this must be a 4, which makes this a 7. That's all messed up. So this is 9, this is 2. Which means this can't be 9, so this still leaves this as an 8. And this as a 9. Because of the 4-5 pair. This can't be 7, so this must be 4 now, which makes this a 1. This can't be 5 or 6, so this is 2. This can't be 2 or 5, so this is 6, which makes that a 5. This 8 means this can't be 8. This is a 9. This is an 8. This can no longer be 6. This is a 2-9 pair, which eliminates 9 here. This can't be 7. These can't be 8 or 4. It's a 2-6 pair here. We have remaining here 1, 3, and 4. We have remaining here 3, 4, 5, and 7. This can't be 4. This can't be 4. We have a 1, 3, 1, 3 pair in row 2, which eliminates 1 and 3 in the rest of the row. This can't be 3. Yeah, that was all weird there. That's fixed though, but that still doesn't give us any other information. Hmm. Uh, hmm. I'm not sure how I got there again. uh, let's go back. Let's make sure we cleared that correctly. Because we had that mistake earlier, so... I do remember this part vaguely, so this does look kind of familiar here. We're going back, well back. Right, okay, so this was the important part, right? We knew we had... Right, we had a 1 here because this couldn't be 1, and there was no other place for 1 in the row. So this had to be 1, which means this added up to 6, 8, or 9 here. So it has to add up with 5, 7, or 8 to add up to 6, 8, and 9. This cannot be 7. So therefore, because it can't be 7, this can't be 8, which means where is the 8? 8 has to be here. What did that lead to? Okay, that led to this couldn't be 8, so this is 5, which makes that a 6. Therefore, this can't be 5 anymore, so this must be a 6. And it has to be 6 and 2 adding up to 8, right? So that's fine. Okay. That's all kosher. We have 3 now, cannot be here or here, so it must be here. That's correct. We should have had the 2 and 8 not be here, so this can't be 2 or 8, so it's 4. I don't know how I did that. Anyways. This all is still fine. This is still fine. This is still fine. This is fine. This is fine. This is fine. It's 6, 7, 8. That's 3 and 8. 1, 4, 9. Right. This is all good. This is fine. This is fine. Yeah, we just had the 4 and the 7, so that's fine too. Okay, so everything else clears out fine. This can't be 4. This can't be 4 or 3 now. This can't be 5. Okay. Does that give us anything else? We know one of those two is 7, but that doesn't help us. Okay. So that was all kosher. It's really about this grid here. And I don't remember how I unlocked it. I remember I unlocked it somewhere here. Okay, let's fill this out again. 2, 5, 6, 7, 9. No, 8. This is 2, 4, 6, 7, 8, 9, but this can't be 8. Oh yeah, this had to be, this is 4. Oh. I solved for this accidentally because I had a 2-4 pair here being really weird. Okay. Yeah, this is how I remembered it. We know 7 and 9 have to be here, but that doesn't tell us very much. My brain is slowing down right now. Okay. This still could be 6 or 7 here. It doesn't help us much. We know 1 is here. It has to be with 6. Oh, right. If this was... So if this was... I don't think either of these can be 1, right? If this one's 1, that makes this a 7, which makes that a 1. Right. So that was a key. This had to be 3 and 8 here, because there cannot be a 1 here. If this is 1, that forces it to be 7, which forces that to be 1. Because that has to be 6. If this is... Wait, is that right? I don't know if that's right. I don't know if we necessarily have to... Could we have a 7, 8 here? We could with 1 and 3, right? So 6 doesn't have to be here either. Maybe that's where I messed up. Yeah. I think... Well, Yeah, I think I did mess up there. Uh, hmm. If this is high, it has to be 6, and therefore this is 1. But we don't know if both of these are high. They could both be low. And if they're both low, it cannot be 1, 4, because the 4 can't be 9. It can't be 3, 4, obviously, because it can't be 9 here. But can this ever be 1, 6? I don't think so, right? If it's 1 and 6, that forces 1. So if this is 6, that forces this to be 1, but then that would be 1. So this can never be 6. So this is 1 or 3. This has to be 7 or 8 then, here. One of these is a low, though, so one of these must be a 1. Right. So, therefore, this can't be 1. This must be 3. This must be 8, right? Which means neither of these can be 8. Whereas the 8 in row 4, it has to be 8 here. I think I remember that vaguely. Okay, so this can't be 8 anymore. Yeah, so I remember that vaguely. One of these is a 1. We're not sure which. Yeah, I do remember that logic somewhat. So this can't be 3 here. This can't be 3. This can't be 8. So we know there's a 5 here. There's no other... Well, 1 could be here. Okay, so this could be 1 still. Maybe that's where I kind of screwed up there, too. This can't be 1 either way. It can't be 2, 3, 8, or 9. So this is 4, 5, 6, or 7. So the 6 could actually be here. So it's 1, 4, 5, 6, 7. This can't be 3. These are both next to that digit. Well, if this is 2 and 4 both being low, they would have to be next to a 9, because the 2 and the 4 would be the only lows possible. But this can't be 9 because of that 9, so these have to be high. So this cannot be, obviously, 5. This is 6, 7, or 9, which makes this a low. It has to have a 9 and at least a 7. And this can't be 2 because of that 2, so this must be a 1. So this is a 1. Okay, I vaguely recall that too. These are both high. This is a high, so this, and it's next to 2 unique digits. This is a low. Whoops. So it cannot, this is 2 or 4. And 4 could be next to 2, 9, but this can't be 9. So this has to be 2. So this is 2, which means this cannot be 2. These can't be 2. Where is the 2 remaining in column 9? It has to be here, right? This is 2. We have 4, 5, 6, 7, 9 remaining in, but this can't be 9 here, in box 6. This can't be 8 or 9. It has to be 7 next to the 2 and the 1. These can't be 7. This can't be 7. So where's the... Oops, that's where... Anyways. This is a 5, 6, 9 triplet now in box 9, which eliminates 5, 6, and 9 in the rest of the box. This becomes a 4, 8 pair. This can't be 6 or 9, so this must be 7, which means none of these are 7. This can't be 4. It's a 6, 9 pair, which forces this to be 7 and this to be 6. So this can't be 6. It's a 4, 5 pair. That forces this to be 3. Due to horseplay in the factory, all knights moves are strictly prohibited. Okay, so that's where we found the knight's move. This can't be 2 or 3. These can't be 7 anymore. 6 has to be one of these 2. No, it doesn't. Right. This could still be 6 here. This can't be 2. This is low, so it's a 7, 8, or 9. This is... Sorry, this is high because this is low. This must be low. It can't be 1 or 4. It's 2 or 3 here. So 2 and 3 cannot be here. We need a 2, 3 pair remaining. And this is 9 with 1, 4, 1, 5, 6, or 7. This 9 means this can't be 9, so this is 6, which makes this a 9. These can't be 6 anymore, and this can't be 6. Where is the 6 in box 5? It must be one of these two cells, which eliminates 6 from being here. Therefore, one of these two is a 6. We're not sure which. We have a 4, 8, 4, 8 pair here. This is 2 or 3, which makes this 8 or 9. This can't be 1. Um, 2 and 3 cannot be any of these cells remaining. This can't be 5. So one of these two is a 5 here. This can't be 1 because of this 1. We can't have a 2, 3 because of the 2, 3 pair here. This can't be 7 because of this 7. This can't be 3 because of this 3. The remaining digits here are 1, 4, 5, no 5. 1, 4, 6, 7, 8, 9. But this can't be 1 or 4. It cannot be 5, obviously, because 5 is one of these. This can't be 1, either of these two places. Because this is a 1. This can't be 7. Oof. Four is one of these two digits. Okay, so then we had knight's move, right? So this digit, let's just go back to make sure. So that, I remember that knight's move. Single chess knight's move, okay. So we know this digit cannot equal this one. Because of normal Sudoku. Sorry, because of arrow, right? Because these two digits add up to that. This digit cannot be here because of normal Sudoku. Can't be here because of knight's move. Can't be here because it's a 1. Can't be here because that's 2 or 3. Therefore, this must be a 6, and it must add up. That must be a 6, which makes that 7. This is 8. This has to be a 2, 4 pair adding up to 6, which means this can't be 2. This is 3. This is 4. This is 5, and this must be a 5. Knight's move, and this is where we had some problems here. I do remember that I got stuck here, so I went going this way. I think this was fine-ish. The remaining digits in column 1 are 1, 2, 3, 4, and 7, right? These are 1, 2, 3, 4, and 9, but 4 cannot be here. These are 2, 5, 6, 7, 8, but 5 cannot be here. Right, and we had something interesting here, right? Basically, if this was a low, it was 1 or 3. If this was a low, it cannot be 2 or 4. It has to be a 1 if that's a low. If this is a low one, this has to be high, Right, remember these were opposites, right? Because one of these, you have 3 digits in between that and then there, right? You can't have both of these be high or both of these be low because you have 3 digits in between them. And you have to have a 5 then on one of the ends at minimum if you're trying to have both of the same set in a German whisper line for both high or both low. So these have to be opposites. Um, Okay, so this can't be 6. This is 7, 8, or 9. This can't be 6. This is 7, 8, or 9. So if this is low, it has to be 1 through 4. This is 1 through 4 also. So if we had low, let's say we had a... Yeah, it's been a while. What was this again? If we had a low here, you could have 1. The problem with this being 1 is that it eliminates all the 1s here by normal Sudoku. It eliminates 1 here by German whisper line, and it eliminates 1 here by anti-knight. So this can't be 1. So if this is low, it could be 2 or 3. 2, 3, or 4. Yes, actually, whatever this digit is, it could be 2, 3, or 4, right? So this digit must equal that. I don't remember how I solved that. This was not correct. So this is 2, 7, or 8, right? Because this digit eliminates that digit from being the same by German whisper lines, eliminates those digits by normal Sudoku, eliminates these two by anti-knight. Cannot be a 5 because it's on a German whisper line, and it could have been a 4. But I remember I eliminated 4 somehow. I think I eliminated this from being high was the key, I think, right? Remaining digits here. So if I eliminated this from being high, this was low if that were the case. So this could be 1, 2, or 3 here. 2, 3 cannot be 4. So it could be 6 here. This is not. This is 1, 3, 6, 7, 8, and 9. This is 1, 3, 6, 7, 8, and 9. How do I get a... Yeah, whatever. 2, 3, 6. So this can never be 6. It can't be 4, 5, right? If this is 6, this becomes 7, 8, and 9. Well, why can't... Oh, this 9 would eliminate all 9s here, here, and here. But then none of these can be 9. So this can't be 6 if that's the case. Therefore, this is 1 and 2, 2 and 3. It cannot be 4 and 5. So I think it would have to be 1, 2, 3. This can't be 4, 5. I guess this could be 4 here. That's possible to be... So why didn't this work? How did I eliminate that? That is a good question. 1, 2, 3, 4. With 7 or 8. I think that kind of works, actually. 1, 2, 3. Yeah. Okay, let's continue with these digits. What are these digits? 1, 2, 3, 4, 5, 7, 8, 9, but this cannot be 5, this cannot be 5. No 3 in either of these places. No 1 or 7, no 1 or 7, no 1 or 7. This can't be 7 because of this 7. Oh, I think it was because of something like here. Both 2 and 4 eliminates these 2 and 4. Because one of these is 2, one of these is 4. Oh, this 4 means this can't be 4. Therefore, this is a 2. That's by anti-knights. This is 2. Okay, so that was part of it. This can't be 2. Okay, that was it. This 2 means this can't be 2. So this would have to be 3 if this was low, right? This is 1. If this is low, that means this has to be greater than that. But it can't be 2 because of knight's move. It can't be 1 because it has to be greater than that if this is low. So if this is low, this is a 3. This can't be 4, 5, or 6. Therefore, it would have to be 7 at minimum, which would force this to be 8, which would force that to be 9 here. But this can't be 9 because, it's, again, it sees these digits by normal Sudoku, this by German Whisper, these by Knight's Move, and 9 cannot be here or 9 cannot be here. Therefore, that doesn't work. Therefore, this is not a low. This has to be a high, which forces this to be low. So this is low. This is high, which forces this to be a 1. This can no longer be 1 here. This can't be 1 here. No 1 here. No 1 here. If we try to make this 7 or 8, I don't think that would work. If this is 7, that would force us to be 6, 3, 2, 1 as a possibility, because 5 and 4 are eliminated here, so the 7 doesn't work. If we try to have 8, so this could be 2 and 4, this is 3 at least. This can't be 4, 5, or 6, this is 7 at least, this is 8 at least, therefore this is 9. So we know this is 9, this is 8, this is 7, this is 3, this is 2. This cannot be 1 or 3. This can't be 7, 8, or 9. These can't be 3. The 3 has to be one of these 2. 2 cannot be these 2 because of this 2. That's a 1, 9 pair, which means this can't be 9. This can't be 9 or 1 because of the 1, 9 pair. In the box, this can't be 2 anymore, therefore this is a 2 here. Which means none of these can be 2. This can't be 1, 9, so we have a 2, 3, 4 triplet here. 3, 7, 8. This can't be 9. No 9 here. No 9 here. No 9 here. Where is the 9? In box 4 of the grid, this grid. Of grid 3, it has to be here. 8 cannot be here, therefore this is 3. That eliminates 3 from here, here, and here. Okay, the rest of this is 1, 5, 6, 7. No, 1, 4, 5, 6. But 1 cannot be here because of normal Sudoku from this one, and it can't be here because of Knight's Move. Therefore, this is a 1. This becomes 9. This is a 1. And we fight the boss in grid 3 before we fight the boss in grid 2, which is similar to how we had it previously. This 7 means this can't be 7. Therefore, where is the 7 in box 4? It must be one of these 2 digits, which means none of these can be 7. Okay, let's fight the boss in grid 3. I don't remember this part. Anti-knights, right. So therefore the 5 had to be here and here, because 5 can never be on a German Whisper line. One of these is a 4 or 6 on one side, with a 4 or 6 on the other side. The 4 or 6 must always be next to a 1 or 9, 1 or 9, 1 or 9, 1 or 9. We have the 2, 3, 7, 8 in between. Um, right, this must be a low, and this must be a high. This must be a low, and this must be a high. One of these could be 4 or 6. Okay, so this is in between two unique digits on a German whisper line. And they have to be, one of them has to be the 3 or the 7. So this can't be 3 or 7. So this is 2 or 8. Similarly here, we have the same idea. This is next to two unique digits on a German whisper line, and one of them must contain a 3 or 7. So this must be 2 or 8, 2 or 8, 2 or 8. This is 3 or 7. This is 3 or 7, 2 or 8. Not 2 or 7, 2 or 8, 2 or 8, and 3 and 7 here. So this 2 and 8 must be opposite of this 2 and 8. We're not sure which one's which. We're going to make that orange, this green. Therefore, this is the green one. This is the orange one. This is green, orange, green, orange, green, orange. This is orange, green, orange. This is green, orange, and green. Okay. Had some funky stuff here. 5 cannot be here, 5 cannot be here, 5 can't be on a German whisper line in column 5, therefore this must be a 5. We know the orange 2 or 8 is here. We're not sure which one it is. Oh, did we have anti-knight? We did have anti-knight. Okay, that was part of the key. So 5 cannot be here. 5 cannot be here. So 5 has to be one of these two digits. Which means these have to be essentially opposites because it cannot contain a 5. If this is 4, this has to be... Okay, no, we know this is low and we know this is high. Because if this is 4, anything below it is a low. Anything above it cannot be 5, so it has to be high. Similarly here, right? 5 cannot be either of these two cells because of knight's move. 5 can't be either of these two cells because of knight's move. So 5 must be one of these two cells, must be one of these two cells, and must be one of these two cells. Well, 5 can't be here, 5 can't be here, 5 can't be here, 5 has to be here. 5 can't be here, here, or here, it must be here. Which eliminates that from being a 5, so this is a 5, which means this can't be 5, therefore that's a 5. We don't know about these, though. This cannot be the orange 4-6 by knight's move because of that. Obviously, the orange 4-6 has to be in row 7 for box 8, but it can't be here. It can't be here because that's in between 2, 4, and 6. That 2 unique digits on a German whisper line. So this is the orange 4-6. Similarly, where is the green 4-6? Say can't be either of these. Can't be here because of knight's move. Can't be here because it's 2 unique digits. So this is the green 4-6 here. Where is the green 4-6? Cannot be here. Can't be here because of knight. Can't be here because this would have to be an orange 1-9 if that were the case, and we already have an orange 1-9 here. Can't be here because of that. Can't be here because of knight's move. Can't be here because, well, could be any of these 3. Okay, this has been a while, so I don't remember exactly what was going on. know the green 2-8 is here. We're not sure where it is, though. The orange 2-8 is here. The green, okay, the orange 2-8 cannot be here. So the orange 2-8 is one of these two. The green 2-8 has to be one of these two. Again, orange 4-6 cannot be here because of this cell. Can't be here because of knight's move. Can't be here, so it's one of these three. Let's just fill these in, I guess. That's not helpful. It's been a while since I remember what I was doing here. Orange 3-7 cannot be here because of this orange 3-7 in normal Sudoku. Cannot be any of these because of knight's move from orange 3-7. Therefore, it must be here. That's the only only cell remaining. So similarly, green 3-7 cannot be here because of this green 3-7. Can't be here because of knight's move, so it must be here because of the only digit remaining. So green 3-7 cannot be here, cannot be here, cannot be here because of normal Sudoku, can't be here because of knight's move from here, so this must be the green 3-7 here. And I think similarly, orange 3-7 has to be there too. Well, what does that tell us? No, I'm not sure. 1 cannot be any of these. Right? So 1 cannot be here anymore. So 1 is one of these two digits. Similarly, where's the 9? 9 can't be any of these, so 9 has to be one of these two digits. Well, the 8 must be next to the 9. The 2, we don't even know if that's necessarily the case. The remaining digits, so the remaining digits are 1, 4, 6, and 9 in boxes 4 and 6. Okay, what does that tell us? I'm not sure. Well, this orange 1-9 cannot be here, so the orange 1-9 has to be one of these two. Right? Because of knight's move from here. Similarly, okay, so the orange 1-9 has to be one of these two, which means it must be one of these two here. The green 1-9 cannot be either of these two, so it must be one of these two, which means the green 1-9 has to be one of these two. Well, if the green 1-9 is here, the green 1-9 has to be here. The orange 1-9 has to be here. We know the green 2-8 has to be here. And the orange 2-8 has to be here. The green 2-8. Okay, so the green 2-8 cannot... What does that mean? I'm not really sure. Let's not do that. Let's go this way. Where is this orange 3-7 in box 7? Cannot be here because of this orange 3-7. Can't be either of these because of knight's move, so it must be one of these two. This cannot be the orange 3-7, so one of these must be the orange 3-7 then. Still could be either one, though. That's not helpful. So this has to be 2, 4, 6, or 8 here, right? Can't be 1, can't be 9, can't be 3, 5, and 7. So this must be 2, 4, 6, and 8. This must be 2, 4, 6, and 8. We have 1, 4, 6, and... Okay, so let's continue down that path. Okay. If this is 4, 6, this is the orange 4, 6. Which would mean the green 1, 9 would have to be here. That's possible. This is 1, 2, 4, no, 5. It could be 6. So it's 1, 2, 4, 6. This is also 1, 2, 4, and 6. This 2, 8 pair eliminates 2 from being there. So this is 1, 4, 6 here. This is at least 3. Can't be 3. This is at least 4. It could be 6, 8, and 9. But again, this can't be 8 because of the 2, 8 pair. This sees it by normal Sudoku. This sees it by knight's move. Okay. Hmm. Hmm. This orange 1, 9 has to be one of these. Interesting. Then it has to be one of these because it cannot be here? No, it cannot be there. So if it's the orange 1, 9, it has to be here. That can't be here, actually. So if it's the orange 1, 9 is here... Okay, we know it's not here, so it has to be here. Can't be here. It must be one of these two. And it cannot be here. Which means we know the orange are the highs. And the greens are the lows. because this one cannot be here. Where else can it be? It can only be here. So this is the 9. All the 199s are 9s. This is a 4 to correspond. This is a 4, 3, 8, 2, 7, 1, 6, not 9. This is 6, 1, 7, 2, 8, 3, which makes that 7. This cannot be 2. This can't be 9 anymore. Where is the 8? The 8 has to be here, because it's greater than everything else. This can't be 8. This can't be 6. This is a 4 or 6, but it cannot be the red 4 or 6, because if it were, this would have to be a 1. So therefore, this is the blue 4 or 6, which makes this 4. This becomes then 1 here. This is a 9. This cannot be, this has to be 6. This is 7. This is 3. There's no 9 here. There's no 1 here. No 4 here. This has to be a 3. This 6-9 pair means this can't be 6 or 9. This can't be 4 because of knight's move from there, so that's a 1. This is a 4. This can't be 1 or 4. This is less than that digit, so this must be 2, which makes that a 6, which makes that a 1. This can't be 1 or 4 here. No 1 or 4. No 6, no 6. This can't be 6 because of knight's move from that 6, so this is 9. This is 6. This could be 7 or 8, but we have a high no matter what. So this is high, this is high, this is high, and these are lows. This is low, this is high. We have 4 lows here, so this must be 5 with 7 or 8. We're not sure which. Because it can't be 6 or 9 because of the 6 or 9 in the box. This can't be 7 because of that 7. This can't be 8 because of that 8. This must be, we have 4 highs here. This is 7 or 8. This is not 4, not 1. It's 2 or 3. So this is 2, 3, or 4. This is 2, 3, or 4, but cannot be 3 because of that 3. Can't be 2 because of that 2. This is 8 or 9. Can't be 6 or 7 here. This is 6, 7, or 8. This is 6 or 8 because it can't be 7. We have 1, 2, 3 here, 1, 2, 3 here. This is 1, 2, 3, 5, 1, 2, 3, 5. No 1, 2 here specifically. No 3 here because of that 3. Okay, this is 7, 8, and 9 here. And then we probably just have normal Sudoku, right? Or actually anti-knight Sudoku. This can't be 3 because of that 3. This can't be 3 because of knight's move from that 3, so this must be a 3 here. This can't be 3. That's 3 in the corner. We celebrate. This can't be 3. This can't be 3. Oh, someone told me I could turn that off. I'm not sure which one that is. I don't remember. Puzzle fog animation. I don't even know what that is. Disable emoji replacement. Hide background. I don't remember. Anyways, let's go back. Let's continue. Therefore, this is 3. We probably have something similar on this end, right? That would be 7s. Yeah, this can't be 7. This can't be 7. This must be a 7 here by knight's move. 4s. This can't be 4. One of these 2 is a 4. Oh, this 4 means that has to be 4. Whereas the other 4, it has to be here. So this is 4, that eliminates 4 here, no 4 here. This must be a 4, which makes that a 2, which makes that a 3. We probably have something similar on the other side. 6, 6, yes, where is the 6? It must be here. 6 cannot be here and cannot be here. It must be here, which makes this 8. This is 7. This is 7, which leaves this as the only remaining 7 in row 3. This can't be 2. Can't be 1, 3, 4. It can't be 6 here because if that's 6, it must be 8. So this is 2 or 6. This is 2 or 6, which means this can't be 2. This 8 means this can't be 8, so this is 5, which makes that a 7. That leaves this as an 8 and this as a 2. Therefore, this can't be 2. Where's the 2 in row 2? It must be here. This can't be 7. We have a 1, 2 pair here. This can't be 1 because of the knight's move, or this 1. So this is a 2, which makes this a 1. This is 5, and this is 3. That leaves this as a 9 remaining. That leaves this as 1, or this can't be 3, so this is 1, which makes that a 3. This is 2, 6, or 9, but cannot be 6. It could be 2 or 9 here. We have what? 3 remaining in row 7, but neither of these could be 3 because of that 3. Therefore, this is a 3. We have what remaining? Something in 8. 4 and 8. Okay, 4, 8, 4, 8, which eliminates 4 and 8 from the rest of the box. This can't be 8, therefore this is 9, which makes that an 8. This leaves this as a 7. This is 1, 4, or 8, but it cannot be 4, so it's 1 or 8. This can't be 1 because of this 1 by knight's move, so this is 4, which makes that a 1. That makes this an 8, which makes that a 4. We probably have something similar here with 9s. Yeah, this 9 eliminates that 9, so this is 6, which makes that not 8 and 9. This 6 eliminates that 6, so that's 2, which makes that 6. This 2 eliminates that 2, so that's a 9, which makes that a 2. This has to be a 1, and this has to be an 8. And that's how we solved that one. So we entered 8 into the puzzle boss cells in Sudokuvania. And we're right now on 2 hours. So since we did that, we're just going to fill that out with an 8. So that's 8. Therefore, this cannot be 8. We unlock double jump. Wait, I don't remember that one. Huh. Double jump. Oh, that was the... That's like the crocky dots, isn't it? Okay, I do remember that. Right. Black double jump dots separate cells where one digit is double the other. Right. Reload. Okay. Man. This can't be 8 because of knight's move. So one of these is an 8. This could be any of them. So that's not very helpful right now. This is an 8. Okay. This can't be 8 because of knight's move from that 8, so this must be a 7, which means this can't be 7, this can't be 7. Remaining digits here are 1, 3, no, 2, 4, 5. Could be 6, 8, or 9, but this can't be 8 because of this 8. Remaining digits here are 1, 4, 5, and 8, but this can't be 1 because of knight's move from here. This can't be 8 because of that 8. This cannot be 1 and 2 because one of these is a 1. It could be 2, 4. It could be 4, 8 as long as this is the 8. And it could be 3, 6 as long as this is 3 and this is 6. This cannot be 4, 5, or 6 because it sees all 3, 4, 5s, and 6s. This can't be 4, 5, and 6 because it sees all 3, 4, 5, and 6. This from normal Sudoku and that from Knight's Move. So this has to be 8 or 9. Can't be 8. Therefore, this is a 9. This cannot be 4, 5, or 6. This is the remaining 4, 5, 6, and 8. But 8 cannot be here because of Knight's Move from that 8, so this must be an 8 here. This is the same digit then as this one. We're not sure which one that is, though. This looks familiar. This is 2, 5, 6, and 8? Yes. But this can't be 8. So 8 is one of these two digits. This is... cannot be 1, 2, 3. It could be 4, 5, 7, or 9. But there's no... Okay, so 9 cannot be either of these two because of normal Sudoku and Knight's Move. So where's the 9 in column 3? It must be here. The 7's one of these two. We're not sure which. The remaining digits here are 1, 2, 3, and 6. But this can't be 1 because of Knight's Move. Remaining digits here could be 3, 6. We have a 4, 5, and a 7 also as a possibility. 9 cannot be any of these two or any of these, so 9 has to be one of these two here. Which means this cannot be 9 because they're both a Knight's Move away from there. This can't be 8. It could be 1, 2. It could be 2, 4, or 3, 6. We're not sure which. This again cannot be 4, 5, 6 or 1, 3, 8. So it's 2, 7, or 9 here. Two, 3, and 4 all see this cell, so this can't be 4. 3 has to be one of these two cells because it can't be here, so this can't be 3. Okay. If this were, well, we don't know. Never mind. It cannot be here. Therefore, the 8 must be here in column 2. Sorry, row 2. This 8 eliminates that 8 by Knight's Move. Therefore, this must be an 8. This 4, 5 sees these two cells. This one from normal Sudoku and this one from Knight's Move. So whatever this digit is, it has to be here. So this has to be 4, 5. This is 4, 5. This is also the pink 4 or 5. So one of these two, one of these two. This can't be the pink 4, 5. This can't either. This can't either, so it's one of these 3. We're not sure which. One of these two is a 6, and they both see that cell, so this can never be 6 here. This can't be 8. We have a 1, 4, 5 triplet here, which means 1, 4, 5 cannot be in the rest of this box. Therefore, this can't be 2, 4. It cannot be 4, 8. This must specifically be 3 and 6, which means this can't be 3, this can't be 3, and this can't be 3. This can't be 6, so this must be a 6 here. Where is the 8? 8 cannot be here. Oh, we've got a problem. We have... Oof. Probably knights... I made a knight's move error here somewhere. Let's go back to when we solved the boss. I'm not good at knight's moves, so this is always going to be problematic for me. Okay. So we got the 8. That is correct. This cannot be 8. We know one of these two is a 3 because 3 cannot be here. So this becomes 1, 6, 7, 8, and 9, I believe. This sees 3, 6, 7, 8. So it cannot be 6, 7, 8. This is 1 or 9 here. Because it sees those. Oh, it sees 1 also. So this is 9. Okay, that's interesting. This sees, again, all of these 3 find normal Sudoku. That one from Knight's Move. So that's 3, 6, 7, 8 quadruplet, which eliminates 3, 6, 7, 8 there. 1 eliminates that from being a 1 by Knight's Move also. So it has to be 9, which means this cannot be 9 here. So this is 9, which means this can't be 9, this can't be 9, this can't be 9, and this can't be 9, because 9 can never be next to a black crocky dot, because it's double that. So this has to be a 9 here. 9 cannot be here, 9 has to be one of these two. We don't know which. 9 cannot be here, it must be one of those two. And 9 can't be here. It cannot be here, so 9 is one of these two, which means this cannot be 9. Because in box 1 and 2, the 9 has to be in rows 1 and 3, which eliminates 9 from the rest of those rows. Therefore, this is a 9 here. Again, this sees 4, 5, and 6. It sees 1, 2, 3. Oh, I think I messed up here, was the key. This doesn't have to be a 9 here. It cannot be 1, 2, 3, 4, 5, 6, but it could be 7, 8, and 9 specifically here. This can't be 8. It could be 7 or 9, and that's where I messed up. So this has to be 4, 5, or 6 here. Okay. This can't be 8 because of Knight's move from that 8, so this is a 7, which means this can't be 7, this can't be 7, and these can't be 7. This 8 means this can't be 8 by Knight's move, so one of these is an 8. Yeah, I messed this one up. That was the key. Remaining digits here cannot be 9, cannot be 1, 3, 8, cannot be 4, 5, 6 because of Knight's move, so it's 2 or 7 here. 1 cannot be here, cannot be here, cannot be here, and it can't be any of these. Where is the 1 in column 7? It has to be here. So this is a 1, 2 pair, which eliminates 2 here, so this is 7. This means this can't be 7. Where is a 7 in box 4? It has to be here. That means this can't be 7. We can't have a 2 here. The remaining digits are 3, 4, 5, and 6, which is fine. This can't be 3. This can't be 7. Oh, well, that forces this to be 9 then. Okay, well. This can't be 8. These can't be 7. That forces this to be 8. Okay, so we still have the same issue. I don't remember. Okay. This can't be 9, therefore this is a 9 here. 8 cannot be here. 8 can't be here or here. So this has to be 8. That leaves a 2, 5, and a 6 remaining as the digits here. This must be... It cannot be 1 or 3. It's one of these is 7, and this can't be 7 by knight's move. So this must be 7. So 7's one of these two. We're not sure which. The remaining digits here are 3, 4, 5, 6, 7. This can't be 7 by knight's move. This can't be 6. This is 4, 5. This is 1, 4, 5, or 8. And again, if we try to make this 4 and 8, that wouldn't work. So it could be 3, 6, as long as this is 3 and this is 6. Or it could be 2, 4. It cannot be 1 because the 1 has to be here also. So it could be 2 and 4 here. How did I make that an 8? I don't remember. I think that might be wrong, though. Oh, this is an 8, so therefore this... We got some problems here. And then this is 1, 4, 5, which makes this 3, 6. But this can't be 3, 4, 5, or 6. Okay, how did we mess this up is kind of the question. So the problem actually still comes back to the factory. I had a problem with the factory, but that was later on. So I'm not, as I said, I'm not good with anti-knights. So this is probably why I'm having problems there. Let's see how... Wait, why can't this be 9? I'm wondering about that. I think this had to be a 1-9 pair? I don't remember. I think it was a 1-9 pair. Yeah. It can't be 3. Yeah, it can't be 3 because of this 3. And that's how it became the 1-9 pair, I think. Let's make sure this logic was solid. I don't know if it was. Okay, we had the anti-knight immediately. We know that the monster is an 8, so we can just do that. Okay, we're going through this again until we get to the anti-knight part. That was the most important one. Well, okay, we didn't. Okay, this cell cannot be either of these because they add up to that. Cannot be here. Cannot be here because of knight's move. Can't be here because that's a 1. Can't be here because that's 2 or 3 at most. So it has to be here, which means this has to be 6 because it cannot be 2 and 3. Because that would eliminate all possibilities for that cell. So this has to be a 6 then because of that. This is then a 6. This is 2 and 4. Which means this can't be 2. This becomes 3, which makes that a 4, which makes that a 5. This 6 makes that 7, 8. This has to be 5. We get to the same problems here. Again, this has 3 digits in between this German whisper line and this German whisper line. So they cannot both be high, they cannot both be low. One of them has to be high, one of them has to be low. So we try to make this a low. If we make this a low, this is 1, 2, 3, 4, 5, technically, but that would be 7, 8, or 9, right? How do we eliminate that 2 was the question. Okay, these digits are 1, 2, 3, 4, 7. These digits are could be 2, 3, 4, 5, 6, 8, and 9. And these digits are 1, 2, 4, 5, 7, 8, and 9. Obviously, 5 cannot be on a German whisper line. This can't be 2 or 4 because this sees both 2s and 4s here. Neither of these can be 5 because of knight's move. This can't be 7 because of knight's move. This can't be 2, 4 again because they both see the cells. Obvious. Oh, I don't know how I got 6. 6 cannot be any of these 3. Okay. So why can't it be 1, 2, 3, 4, 7, 8? How did we eliminate the 2 was the question, right? Because we did eliminate the 2 somehow. I'm not sure how, though. This can't be 8 because of knight's move from that 8. Maybe that's why this was messed up. This seems like it should be fine. Huh. No, but the answers were clearing things, so obviously that was correct. I cleared the 2, but I don't remember how I cleared the 2. Obviously can't be higher than this. Okay, these were 1, 3, 6, 7, 8, 9. But this can't be 7 by knight's move. This can't be 6 because of knight's move. This is 1, 2, 3, and 9. It cannot be 4, 5, 6, 7, 8. This can't be 3 because of knight's move here. This is 2. No, 1, 2, 3. No, 1, 3, 4, 5, 6, 7, 8 here. So this digit cannot be these because of normal Sudoku. Yeah, the question is, how did I clear the 2? Because if this is 2 or higher, that would be 2, 3. It cannot be 4, 5, 6, so it would be 7. Then that would be 8 and 9. But the problem is, this sees all the cells here, right? These 2 by knight's move. These 2 by normal Sudoku. This one by German whisper line. So there can never... This digit cannot be any of these digits then. It could be 5, but can't be 5 on a German whisper line. It has to be either this cell or the 4. So this can never be 9. It's 7 or 8 here. So this would have to be 1, 2, 3, 4, 7, 8, if that were the case. Well, one problem, okay, that's why. This 4 makes this not a 4. So this is 2, that's a 4 because of anti-knights. Right, we have... Okay, so that was all fine. I must have messed up some anti-knight thing. I'm not good with anti-knights, so... Cells separated by a chess knight's move cannot contain the same digit. Okay, so that's just there. Okay, so this 2 means this can't be 2. So this cannot be low. I think this is still all kosher. This can't be 2. This can't be 2 by normal Sudoku. This can't be 4. No 4 by normal Sudoku. This can't be 4 by Knight's move. We tried this going high. So this can no longer be 2. It would have to be at least 3, which would force this to be 7, 8, and 9. But that doesn't work because 9 sees all the 9s in box 8 see that 9, that cell. So this cannot be 9. It can't be 7 or 8 because we can no longer have a 2 here. So it can't have 1, 2, 3. So again, it'd be 1, 3, 7 at minimum, 8 and 9. Therefore, this is a low. So this is 2 or 4, which makes this a 7, 8, or 9. This 2 or 4 goes to 3 at minimum. It cannot be 4, 5, 6. It's 7 at least. 8 at least, 9 at least. So this has to be 9, 8, 7. Cannot be smaller than a... cannot be greater than a 4, I'm sorry. So this has to be 3. This is 2. This can't be 8 anymore because of this 8. By Knight's move. This can't be 8 or 9. This can't be 7 because of Knight's move. This can't be 3 because of Knight's move. This can't be 2 because of normal Sudoku. This can't be 2 because of Knight's move. We have a 1, 9, 1, 9 pair, which eliminates 1 and 9 in the rest of the box. This is a 1, 9 pair. This can't be 1 or 9. This can't be 9. This must be a 7. So this is a 7, which means this can't be 7. This can't be 2 or 3. This has to be a 1, because that has to be a low next to the 9. These can't be 1. This can't be 1. This can't be 1. These can't be 9. This can't be 8 or 9 because of the 8 here and the 9 here. So this is a 3, which means none of these are 3. This can't be 9 because of a Knight's move here. So where's the 9? It has to be here. Ugh. And we still run into the same problem. This can't be 1, so this has to be a 1 here. Which forces this to be 9, which forces that to be 1. This has to be a 2 because that's the only digit remaining. This is a 4, 5, 6 triplet. This can't be 7 because of Knight's move from that 7. So one of these is a 7. Oh. We know this is an 8. Okay, we still have the same problem. Okay. 1 cannot be any of these 3. 1 cannot be any of these 3, therefore 1 has to be here. It's a 1, 2 pair. Eight's one of these two. 8 cannot be here or here. 8 has to be here because this is an 8. 8 cannot be here. This can't be 8 because of Knight's move from that 8. Therefore, this must be an 8. Which means this can't be an 8 here, so this must be 8 here. This is a 3, 6 pair because this is 1, 4, 5 here. This is 2, 3, 4. This can't be 1 because of 1 from the Knight's move. This becomes 5, 6, 7, 8. We have 1, 6, 8, and 9. This can't be 1 or 8. It's 6 or 9. This can't be 9 because of the Knight's move from there. This can't be 1 or 4, so this has to be 3 and 6. We know for certain this is 3 and 6. This can't be 6. Therefore, this is 6. We have what? This can't be 2. This can't be, none of these can be 6, so this must be then 9. This can't be 6, this can't be 6 or 9, therefore there's no 8. This can't be 6, this is 5, 6, 7, which forces this to be 8, which means this can't be 8 here. We have 2, 7, 8, 9. This can't be 2 or 8, so it's just 7, 9. But the problem is that we have the 9 here then again. Still. How did I... I don't know how I broke this. The 1 is obviously correct there. This is annoying. What am I missing here? I'm missing something obvious, but I'm not sure what it is. I don't know if I'm missing something obvious. I'm just not good at knight's moves, so I just don't. Does this have to be 3? Could it be 4? It could be 4. Maybe that's where I'm messing up. Yeah, I think that's where I'm messing up. It has to be 2 there. But it doesn't have to be 3. I think that's where it is. Okay. Right. I think it does have to go 9, 8, 7. This cannot be... Yeah, this has to be 7. This has to be 3 or 4. It cannot be 5 or 6. But it still could be 3 or 4, and therefore this is 2. Got it. Okay, so that's it. This can't be 2 anymore. Cannot be 2 anymore. This can't be 2. Where is the 2? It has to be here. Again, this can't be 8 or 9, so this is 3, which means this can't be 3, this can't be 3, this can't be 3 here. This has to be a 1 next to the 9, because there needs to be a low. And it can't be 1, 2, it can't be 2, 3, or 4, so this is not 1, this is not 1, this is not 1. This can't be 7, so one of these two is a 7, that's good. This can't be 8, so one of these two is an 8. This can't be 9, and this can't be 9, and this can't be 9. So therefore, this has to be a 9 here. 1 cannot be here. 1 cannot be here, so this is 1. Okay, so yeah, I was messing this part up. That was where it was messing me up. So this is 8. This cannot be 1. This can't be 1 either. This can't be 8 or 9. It's 1, 3, or 6. This is 8. 1 cannot be... 1 has to be one of these two. So the key was I was messing that up. Okay, that wasn't knight's move. It was just thermometer mess-ups. 8. This is 3, 4, 5, and 6. So 3 cannot be here. So 3 is one of these two digits. Where is the 8? Can 8 be here? No. So 8 has to be one of these two digits because it cannot be here. So 8's here, 8's here. 8 cannot be either of these, therefore this is 8. 8 has to be one of these two in column 3, so it can't be here, can't be here, can't be here. This must be an 8. This 8 eliminates that 8 from being normal Sudoku, therefore this is an 8 here. This is 3 or 4. We have a 1 and a 5 here. And we have 3 or 4. This cannot be 1 because of knight's move here. Well, we know this 3 doesn't work. I don't know if, yeah, I don't know if we should, anyways. This cannot be 1. If it's 8, it's 8 and... Okay, so... Huh. I don't know if there's a way to solve that without running through those things. Anyways, this is 1, 2, 3, 6. This can't be 1, though, because of this 1. These digits are Can't be 2. Could be 1, 3, 4, 5, 6, 7, 9, technically. This cannot be 9 because of knight's move. This can't be 1 because of knight's move. This can't be 3, 4, 5, 6 because it sees all of those by normal Sudoku and knight's move. This also sees 3, 4, 5, 6 because it sees them all from normal Sudoku and these two from knight's move. So this is, it could be 1, 2, 3, 7? Okay, so no 1, could be 2, no 3, 4, 5, 6, could be 7 or 9. So one of these two is a 9. 8's one of these two. One of these 3 is 1, 2, 3, 4, or 9, right? This cannot be 1 because it sees both of these 1s in row 6. This cannot be 1 because it sees both of those 1s in row 6. But 1 could be here or here. I'm not sure which. Remaining digits here are 5, 6, and 5, 6, 7, 8. Yeah, we know this can't be 3 anymore. Is there a more elegant way of showing that, though? I don't think so. We have a 179 triplet in... Yeah, we have a 179 triplet in column 5, which eliminates 179 in the rest of the column. Therefore, this can't be 7. We also know one of these 2 must be a 3, so this can't be 3. Again, cannot be 1, 2. It could be 2, 4, or 4, 8 if this is the 8. Or 3, 6 if this is 3, and this is 6. This is 2, 7, or 9. One of these 2 is an 8. This one sees this one, but okay, well, this can't be 8 because of this 8, really. So this is 1, 2, 3, 4, or 6. Okay, remaining digits here are 2, 5, and 6. 2, 5, and 6. Remaining digits here are 1, 2, 3, 4, and no 7 because one of these 2 is a 7. Here we have 4, 5, 7, and 9. And one of them has to be... This can't be 9 because of this 9. This cell must be the same as this cell. This cell could actually be that one. No. So that's not helpful there. Yeah, I don't know. There's no other way except for tracing this out and then seeing that the 3 breaks everything. Or sorry, 3 being there breaks everything because that forces this to be 3, 6. This 3 eliminates that 3, so that's 9. This is 1, which eliminates 1 here by knight's move. This can't be 1 anyways by knight's move, so this must be 1, 2. 1, 2 can't be here. 2 can't be here. 2 can't be here. 2 has to be here. but we're forced to have a 7-9 pair here, but 9 has to be here. Because 9 cannot be here. 9 cannot be here. But this is 7, right? So you have 1, 2 here. Okay. Yeah, I don't even remember what the issue here was specifically, but I remember just running into this problem over and over again. So if this is 3, that means this is 1, 4, 5, which forces this to be 3, 6. 1 can't be here. This 3 means this can't be 3. This is 9, which makes that 1. None of these could be 1 anymore. None of these could be 9 anymore. This can't be 3. This can't be 3. This has to be a 1, 2 pair here, which eliminates 2 here. This 9 makes this a 7, which means this can't be 7. Can't be 6 because of that 6, so this is 9, and therefore this must be 7. But where is the rest of this cell? I don't know. This has to be a 3. This can't be a 7. This has to be 6. Why did I run into issues again? I don't even remember. This is 4 and 5. Ah, this is 4, 5, and this has to have a 1, 4, 5 here, which is why it runs into issues. That's pretty complex. I don't like that. Anyways, I don't know if there's another way of showing that. So this is 4. This cannot be 4. It's a 1, 3, 5 triplet, which eliminates 3 from the rest of the box. So this is 4 here, which means this cannot be 4. This cannot be 4. These can't be 4. This is a 5, 6 pair here, which makes this a 3. This can't be 3 here by knight's move. This can't be 4. So this is the same as this by 5 and 6. You don't know which one it is. This becomes 2, 4, 7, or 9 as possibilities. Cannot be 4, though, because we know the 4 has to be one of those 2 cells. So this can't be 4. So it's one of those 2. We're not sure. This cell cannot be any of these. So this is a 4. This 1, 3, 5 all sees that cell, so this can never be 3. One of these 2 is a 4, but that's not helpful. Five and 6 has to be here. 3 eliminates that 3. Remaining digits here. One of these is a 6. We're not sure which. We have 2, 4, 5, 6, 7, 8, but no 8, no 4. So 2, 5, 6, 7, 8. This can't be 8. 2, 5, 6, 7, 8. But this can't be 8. Aha. Right, that's why. The 8 can't be here. 8 can't be here. 8 can't be here by knight's move. 8 can't be here by knight's move. 8 can't be here because of that 8. So this must be 8, which makes this a 4. This can't be 8 then. This can't be 8. We know one of these 2 is an 8. It's not that helpful. One of these 2 is a 6. One of these 2... Okay, this can't be 5. So one of these 2 has to be a 5 then in row 4, which eliminates 5 here. Hmm. So 4 in row 4 has to be one of these two cells. Well, this sees that cells by normal Sudoku. This sees that cells by knight's move. Same here. This sees that cells by knight's move, and that sees that cell by normal Sudoku. So neither of these can be 4. 4 cannot be any of these. 4 cannot be any of these. Where is the 4 in row 7 then? Or row 3? It has to be here. So this is 4. The remaining digits can be 3, 5, 6, 7, 9. This 4 eliminates that 4 as a possibility by knight's move. So 4 cannot be here. 4 cannot be here. 4 is one of these 3. We know 5 is one of these 2. Hmm. Okay, this cannot be 1 because it sees both ones in possibilities in box 8, and those are the only 1 possibilities. So this can never be 1. This could be 1. Hmm. Okay. 3 cannot be here because of knights, anti-knights here. 9 is one of these 3. We're not sure which. Hmm. Okay, this can't be 2 because of anti-knight here. So 2 is one of these 2, which is fine. Doesn't tell us much, though. 1 again is one of those 2. We have 1 and 3 here. That's not helpful. This can't be 3 because of knight's move from this 3. So this is 1 or 2. Remaining digits here. Okay, so this that we just know that can't be 4. That doesn't really tell us much. Hmm. Huh. Okay. 2 has to be one of these 3 because of these 2s. And if it's here, it sees both possible 2s. Well, it doesn't have to be there. Dang it. 6, though. Okay, this has to, one of these 2 has to be a 6. So this cannot be 6 here. Because both of these 6 possibilities see that one. Um. Hmm. Uh. Hmm. 8 has to be one of these two. That's not helpful right now. We know 5 is one of those three. That's not helpful right now. That's one of those three. That's not helpful right now. If this is 3, 6, that forces this to be 5. Okay, so if this is 3, 6, we're left with 5. This must be 7. Which makes that 2 and that 9 and that... Oh, we don't have a possibility. Right? Because this would have to be both 1 and 4. 1 can't be this one because it sees both of these. 1 can't be here because of that 1. 4 can't be either of these because of the 4s here. Cannot be any of these because of that 4. And 1 can't be here because of this 1 here and that 1 and this 1 by knight's move. So if we try to make this 3, 6, it doesn't work because both 1 and 4 would have to be here. So we know this is actually 2. So this is 2 with 1 or 4. We're not sure which. This can't be 4 though. One of these is a 2. Since one of these is 2, none of these can be 2, so one of these two has to be a 2, which means this cannot be 2. Where is the 2 now? In box 9. It can only be here, so this is 2. So one of these is a 2. One of these is a 2. This is 1 or 4, and this is 1 or 4, right? Those are the only places for it. I guess it was a 3, 5, 6, 7, 9 quintuplet to figure that out. But anyways. Remaining digits in box 3 are 1, 3, 4, 5, 6, 7, 9. Okay. 4 cannot be here or here by normal Sudoku. 6 cannot be here by knight's move. 9 cannot be here by knight's move. I'm not good with these. 9 cannot be this one because of knight's move. From these two 9s. This can't be 6 because of knight's move and normal Sudoku. We don't have any information there. Actually, let's make this pink orange. And we'll make this a pink. Well, can't be here. Can't be here. It's one of these 3. Which doesn't tell us much, unfortunately. This one can't be here. So it's one of those 4 corners. Okay, this orange 5 or 6 cannot be here because of knight's move and normal Sudoku. Can't be here because none of those can be 5 or 6. So it has to be one of these 2. So since the orange is here, orange cannot be here. That means the orange has to be one of these 2. We're not sure which. Okay. Do they see any other ones? I don't know. It's also one of these 2. Oh. Well, the orange has to be one of those 2. The orange has to be one of those 2. That means the orange must be one of these 3. But that doesn't really tell us much. Um, Orange can't be here, so it's one of the four corners. That's not helpful. Uh, Pink. I don't know what pink can be. Pink cannot be here. So pink, interestingly enough, has to be one of these two. And then one of these two, right? And they could be any of these three. Oh, this can't be 6 then, right? This orange has to be the same as that one, right? This pink sees that one, and this orange sees that one, so this can't be 5 or 6. It has to be 2 or 3. Still not helpful, though. One of these is a... No, we don't know. One of these 3 is a 7. That's not very helpful. Hmm. Hmm. I don't think I unlocked any rules, did I? Ugh. No, I did not. Oh, I did do... Yeah, but I don't see anything here that I can use it on. I don't even remember how I unlocked the other stuff to be. It's been a while. Um, let's see. So pink has to be one of these 4, but that doesn't tell us much, right? Hmm. Hmm. Mm hmm. Oh, this can't be 6 because it sees 5 and 6 is here. So 6 does have to be one of these two. Well, those both see that 6 by Knight's Move and normal Sudoku. We would have been able to see that anyways. Mm. This digit sees all 4 of these digits. So those are 4, 5, 6, 7, 8. So this cannot be 7. This is 3 or 9. Hmm. Hmm. Not sure what else we have. This digit sees all of these 3, sees these 2 by Knight's Move, and this is 2, 4, 5. So this must be the same as that. Okay, what does that tell us? I'm not really sure. It has to be one of these two. Because this sees it, my Knight's Move and 3 and 9 cannot be here. It can't be that one. It's one of those two. And it's one of those two, obviously. Hmm. Uh, hmm. Hmm. If this is 9, this becomes 3, which makes that 5. Therefore, this is 6 or 7. And this is 6 or 7, which would force that to be 9. So if that's 9, this is 9. If this is 9, it's... Okay, if this is 9, this is 3. This actually has to be 6, I believe, right? This becomes 9. This makes this a 7. Therefore, that makes that a 6 by Knight's Move. If this is a 7, though, that makes things interesting, unfortunately. Hmm. I think my brain is a little fried right now, just from having to redo all of this. So we're gonna stop right now. This is becoming a very, very long series. I don't know how I'm gonna break this up, essentially, but we'll continue on next time, and I'll see you next time on hopefully solving more of this puzzle. We just had to redo a whole bunch of stuff, and we are still many grids away. We have 1, 2, 3, 4. Can't tell what that is. So we have 1, 2, 3, 4, 5, maybe 6 here for this connector. After this, we eventually got to solve this, which allowed us to clear here, which allowed us to clear here. But then we ran into a problem. And then I cleared my cache, which unfortunately cleared a whole bunch of stuff on this. So that kind of broke things. Anyways, I'll see you next time as we continue Sudokuvania. Take care.